This lesson starts by defining what's called a central angle. And the way a central angle, or what a central angle is if I take the center, we'll call the center C, and I pick 2 points on the circle, we'll call this first one A, and we'll call this one B, and I connect those 2 points to the center, that creates an angle. And again, we call that angle ACB a central angle because C is the center of the circle. Okay. What that does to the actual circle part is that creates 2 arcs. Okay, now this first arc here, we'll call it arc AB. All right, we notice we put a little arc on top, so know we're talking about an arc, not a segment or anything else. Okay, this is called a minor arc. All right, the reason it's called a minor arc is because it is less than 180 degrees. All right. Now to talk about this other side, we have to introduce a third point. We'll call that point D. All right, and this is going to be a major arc. All right. And so that I can tell them apart, I have to introduce that third letter. So that's why it's ADB. And we still put the arc on top. Okay. If this one's less than 180 degrees, a major arc is going to be greater than 180 degrees. Okay. Now, if I take this off right here, and let's say that I move this point A directly across the other side from B, so that this goes straight across and makes a straight line, okay, then this is what's called a semicircle. We would say that the arc ADB is equal to 180 degrees. Okay. That means that this is a semicircle. Another way of saying that, another way of looking at this is if segment AB is the diameter, then the arc is a semicircle. Okay, to give it more of a formal definition. If I know that the central angle is 50 degrees, that means the measure of the arc is also 50 degrees. So with the central angle is equal to the measure of the arc. So if this is 50 degrees, you know the arc is 50 degrees. So the measure of the major arc is going to be 360 degrees minus the minor arc of 50 degrees. And so that would be 310 degrees. All right, this example says find the measure of each arc of circle P where RT is a diameter. So for this first one, we want to look at arc RS. Now RS is here, and if we look at the angle that's made from R to S, we have this angle RPS, which is a central angle. So that tells me that this arc here is equal to the central angle, which is 110 degrees. Okay. Now if I look at arc RTS, right, that's coming back this way from R to T to S. So that one is going to equal 360 minus 110, which is 250 degrees. Now for RST goes from here to here. And remember that it said RT is a diameter, which means that this arc RST is a semicircle, which means that it is going to equal 180 degrees. All right, now we're going to talk about what's called the arc addition postulate. And that just simply says that if I have 2 arcs here, call this one AB, and we'll put another point here, we'll call that C. All right, so that what that arc addition postulate says is that if I want the measure of angle, or excuse me, arc ABC, it's going to equal the measure of the arc of AB plus the measure of the arc of BC. Okay, so that just means that I can take these 2 smaller arcs and add them together to get the major arc. So now we're going to look at using this arc addition postulate. Find the measure of each arc. I want to find first the arc GE. So GE would go this way. So that means I would just add the 40 plus the 80, which would equal 120 degrees. Okay. Now to find GEF, so I have to go from G to E to F. That means I would need to add the 40 plus the 80 plus the 110. That's going to come out to be 230 degrees. Okay. Now if I want arc GF, that means I'm going to have to go this way, which means that's going to be equal to 360 minus the 230, which would be equal to 130 degrees. Two circles are congruent circles if and only if they have the same radius. The congruent central angles theorem says in the same circle or in congruent circles, two minor arcs are congruent if and only if the corresponding central angles are congruent. So now we have this example that says tell whether the arcs are congruent. For this example A, I want to know if this arc CD is congruent to this arc EF. Now because they're inside the same circle and they both have B as their vertex, that means they're both central angles. And since these two are equal, these two angles are congruent, that means the arcs are congruent as well. Now for B, they both have this 90-degree angle. It is a central angle, but because these two circles are not congruent, I know this because this is a concentric circle, it's inside the outer one. They don't have the same radius, so that means that they are not going to be equal. Down here, on this example C, I do have two central angles, and they both measure 95 degrees. And I know this circle T here is congruent to this circle X because the radii are congruent as well. So that tells me that for this arc UV, it would equal the same measure as arc YZ because the circles are congruent. So to kind of summarize this, I have to know that the circles are congruent in order for me to be able to say that the arcs are congruent. Here it's the same circle, so they have that same central angle measure, which means that the arcs are going to be equal. Here I don't have congruent circles, so there's no way that these arcs are going to be congruent. Down here on this third example, I do have congruent circles. I know that because of the radii being congruent, which means that I have congruent circles, and since the central angles are equal, that means the arcs of those central angles are also going to be equal.